Hello, everyone. Hey, my name is Ashod Nakashian. I go by Ash. I'm going to talk about the async saving improvements that we did. But very briefly, just to give context, what is this async saving about? Basically, whenever the document is modified, we need to preserve the contents. You hit the save button and something magical happens behind the scenes. Basically, what happens, first of all, is the document needs to be stored in the file format of your choice. And then after that, it needs to be uploaded to your storage. That is a two-step process. And ideally, what you want is you want to continue editing the document whilst all of this machinery is just grinding away in the background. You don't want your UI to halt. You don't want to have any noticeable pauses and glitches and so on. So the work that we did basically is to, first of all, separate these two logical steps from one another and make sure that they're both done asynchronously. Meaning, if you have saved and whilst uploading, let's say the server timed out, is too slow, you've made some more modifications, hit save again, you should expect that all of your modifications are saved and then uploaded as expected, regardless of whether one step had failed independent of the other. And all of this is supposed to work basically without any overheads, any new requirements or anything like that. So that was the work that was done, I believe, mostly last year, and it's already available in production. But the follow-up was basically to improve on it. This is a rough diagram. As you can see, it's very minimalistic as to how we leverage the idea of having all the connections that we get from the users into basically a single internal pool so that we do not have any excessive threads or anything like that. So all the connections basically end up in one single pool, and that helps us to reduce the resource consumption. And at the same time, we know that when we're, for example, getting a save command, that save is going to be executed before the subsequent modifications. But I'll have more to say about that save whilst modifying issue. So the improvements that we did after having the feature out were numerous. These are some of the highlights. And one of them basically had to deal with the fact that you do not want your data to be lost for any reason. You really, as a user, do not care what's happening in the background. You really don't care if the storage server has some slowdown, outage, or anything like that. What you care about is that your data is safe. So you have edited your document, and whether intentional or not, you close your browser window. That basically disconnects you from the document. Now, in a normal case, we save, we upload, and then you'll find that all your latest changes were there when you come back to your document. But that is obviously the ideal case. Well, what happens, for example, if the document had been modified by somebody else or somebody uploaded a newer version when you were basically working on the current one, and now that you've closed your browser, you can no longer resolve this conflict, whether you want to override the changes that were done by your colleague, or you want to basically lose your changes and maintain whatever was there. That is done normally via an interactive pop-up in the case that you are still connected to the document. But if you close the browser, it's gone. So that was one basic case, and now that we have a quarantine mechanism, we rely on that, and we try to be smart about it so that we do not basically wait too long before we decide that, no, this user is no longer available and we can't resolve this conflict. We will just need to rely on the quarantine environment. That was one of the things that we did. Other than that, we've improved the way that we track and control the timeouts and the retry attempts, and how frequently do we want to retry a failed upload, for example, and how much to wait between them, and how many times do we retry before giving up. All of these things basically improve the control that an admin can have over the system, because they know the storage server, and they can basically decide what kind of SLA the server can provide and how they want to interact with it in case of a failure or timeout situation. And we have some configuration settings basically added so that we give that control to the admin to say basically retry up to 5 times, waiting this many seconds between them, but no more. And then you fall back again to the quarantine idea. Basically, you give up at some point, preserving the document on disk locally on the server, not the storage. So basically, we cap failures, we cap the retrying, and we limit the number of the attempts that we're doing. Other than that, we've made sure that unloading is now much faster, regardless of whether it's successful or unsuccessful. Why is that important? Well, because you want to reduce load on the server as fast as possible, but also you want to make it faster and more responsive for the user to reload the same document. You do not want to get in a situation where, hold on, I'm still figuring out how to, unload your previous session before I, open the document again and so on. So we want to do that as fast as possible. That's what we did. Other than that, we have a number of races. Basically, I've mentioned that you might be saving the document, and that takes a certain amount of time, especially if whilst uploading your document is large, you have embedded videos and images in it and so on. So it's a big document. And at the same time, you're modifying again and you're saving, or maybe your colleague is doing that. So you have all these race conditions. And at some point, you might be making a modification after a save and close your browser. You should expect everything to work in the order that you've carried out these commands, right? You basically finish the save, make the modification, and then save again before you ultimately unload the document. This is obviously easier said than done because all of these things are happening in parallel. Your modifications are coming through the network. At the same time, there is a save happening in the background, and there might have been an upload that is still in progress, or there might have been a previous failure. So you see all of these things are now happening concurrently. And at the same time, since you've closed your browser window, there is an imminent unload or basically ultimate termination of the whole document that is outstanding. Right, and as I said, we want to do that as fast as possible, but not faster than we can preserve the data. Right. So these races basically resulted in rethinking how we're going to track everything. Now, to make things even more complicated, whenever you save a document, we give the integration the ability to add what we call storage properties. So you can, for example, dictate overriding any version that isn't in storage, so you can force overriding it. You can change some of the properties by passing certain IDs or tokens to the storage, that then the storage would use them to do basically implement extensions to the save model. It can be temporary tokens for authentication. It can be way to say replicate this or don't replicate this. This is time sensitive. It could be anything. And now this adds another level of complexity over everything that I just mentioned, which is every save basically can come with extra information and settings and flags. And when you fail to upload, the subsequent save might have changed some of these properties, and you don't want to lose the previous one, right? You don't want to clobber, you don't want to basically override in your retry attempt with the new properties, because that is unexpected from the user's perspective. So what we do is we preserve the previous one, and we make sure that retry is being done preserving whatever properties were set from the browser. And typically what the integration does is the integration environment in the browser has some sort of a communication channel, either that happens at load time or might be dynamic with the backend. So we cannot just ignore or drop these properties. We have to preserve them. And that was part of the attempt to basically separate every request to save and basically preserve whatever properties that were sent down to us in that save request until we successfully upload and make sure that the document is preserved. All of this basically wouldn't, first of all, be so easily possible to implement, and we wouldn't be able to defend them if we don't have proper testing. So hardening the feature definitely is key. One of the things that we started with basically was to reproduce these conditions. So it's easy to come up with these scenarios, like I just did. I described, you do this happens, and then you do that thing. But it's more difficult to reproduce them consistently, and you don't want to do it manually. Obviously, you don't want to spend your time trying to reproduce these time-sensitive, events. So what we did, basically, we improved the testing environment, the framework, to allow us to reproduce these conditions reliably, make sure that we actually can achieve the conditions that we expect the thing to work, have your checks that fail, right, if it doesn't work, and then fix it and make sure all of your checks are now passing. And that basically proves that, first of all, you've reproduced the conditions, you have reproduced the failure, if there was one. If not, then job done, great, you move on, but if not, then you go and fix it, and then the test is going to defend that fix so that it doesn't regress. And that was basically a very important step in all of this. In addition, we've added more fuzzing, which basically is a way to intelligently generate commands, requests, and conditions and inputs that humans normally wouldn't do, but that trigger certain edge cases, paths that might actually be problematic. And once we catch something, we fix it. So with that, thank you so much. And I'm happy to answer questions.